Question number 1. Let A 1, 2, 3 up to 14 define a relation R from A to A by R x comma y such that 3x minus y is equal to 0 where x and y belongs to A. Write down its domain, codomain and range. So in the given data we have A which is having elements 1, 2, 3 up to 14 and we have the relation 3x minus y is equal to 0. So here when you are going to input 1 then we get y 3 minus y is equal to 0. So y is equal to 3 here. So 3 when you input 2 so y will be 6 here. So in the same way 3 when you are going to input you get y is equal to 9. Same 4 when you are going to input we get y is equal to 2. So in the same way 5 when you are going to input then y value we are getting 15. 6 we get y value 18. 7 y value we are getting 21. 8 when you are going to input we get 24. 9 we get 27. 10 we get 30. So in the same way 33, 36, 39 up to 42 we are going to get the y values here. When you are going to see in a diagrammatic manner, so 1, 2, 3, 4 in this way the outputs we are going to get 3, 6, 9, 12. So this will be the diagrammatic manner. So up to 14 we are going to see 42. So this is x element, this will be y element. So in this we are going to see domain here. So domain is equal to 1, 2, 3 up to 14 and codomain will be y values. So that will be 3, 6, 9 up to 43 and the range when you are going to see so that will be from 3 to 42. So here we are going to see codomain equal to range here. Question number 2. Define a relation R on the set n of natural numbers by R x comma y such that y is equal to x plus y. X is a natural number less than 4. X and y belongs to n. Depict this relationship using roster form. Write down the domain and the range. So the relation given here is y is equal to x plus y and x which is less than 4 here. So when you are going to input y, x value 1 here, then y value we are going to get 6 here. So when you are going to input 2, then we are going to get 7. When you are going to input 3, we are going to get 8 here. In the question they have given x is less than 4, we can't input 4 here. Now in the roster form when you are going to see the relationship, so that will be 1, 6, 2, 7, 3, 8. So this will be in the roster form. And domain, when you are going to see, so domain will be 1, 2, 3, and range will be here output 6, 7, 8 is the range here. Question number 3. A 1, 2, 3, 4, 5, B 4, 6, 9. Define a relation R from A to B by R x comma y, the difference such that the difference between x and y is odd. X belongs to A, B, y belongs to B. Write down in roster form. So here the difference should be odd, that is the condition, and x and y, the data is given here. So here we are going to frame a relation here so that the difference should be odd here. So here first one, when you are going to see 1, 4, the difference is odd. So first we are going to get 1 and 4, next 1 and 6. So this also we are going to get the difference odd, that is 5. Next 1 and 9. So the difference is 8, which is even. Next 2, 4. 2, 4 difference is even. 2, 6 difference is even. Next comes 2, 9. The difference is odd here. So the 2, 9. Next 3, 4. 3, 4 difference is odd. Next 3, 6. The difference is odd. Next 3, 9. The difference is even. Next comes 5 and 4. The difference is odd. Next 5, 6 difference is odd. Next 5, 9 difference is even. So this is the roster form. Question number 4. The figure shows a relation between sets B and Q. Write its relation in set builder form and roster form, and also write domain and range here. So here we are going to see two sets P and Q, and the relation first we are going to find out. So here we are going to see 5, 3, 6, 4, 7, 5, so which is less than minus 2. So we can say that x minus 2 is equal to y. So this is the relation. So first we are going to write in a set builder form here. So here x such that x belongs to n here, so which is natural number, and x range is from 5 to 7, which is equal to 5 and also equal to 7. Next x minus 2, that will be equal to y here. So this is the relation. This is set builder form here. And coming to the roster form here, here we are going to see 5 and 3, next 6 and 4, next 7 and 5. So this will be in the roster form. And domain, when you are going to see, domain is 5, 6, 7 here, and range when you are going to see, so that will be 3, 4, 5 here. So this will be range and this will be domain here. Question number 5. Let A 1, 2, 3, 4, 6. Let R be the relation on A defined by A comma B such that A and B belongs to A. B is exactly divisible by A. So write in roster form, write the domain and range here. So here the condition given is B should be exactly divisible by R here. So here we are going to see the elements which are given 1, 2, 3, 4 and 6 here. The condition given B exactly divisible by A. So here 1, 2, 3, 4, 6 are exactly divisible by 1 here. So that will be first. Next 2, 4, 6 will be exactly divisible by 2 here. Next 3, 6 exactly divisible by 3 here, and 4 will be exactly divisible by 4, and 6 will be exactly divisible by 6 here. So we are going to write in a roster form here. R. So first 1 and 1, so which is exactly divisible. Next 1 comma 2, 2 is exactly divisible by 1. Next 1 comma 3, next 1 comma 4, next 1 comma 6. 1, 2, 3, 4, 6 exactly divisible by 1 here. Next 2 exactly divisible by 2, so 2 comma 2. Next 4 is exactly divisible by 2, that will be 2 comma 4. Next 6 is exactly divisible by 2, 2 comma 6 here. Next 3 exactly divisible by 3. Next 3 exactly divisible by 6 here. Next comes 4, which is exactly divisible by 4. Next 6 exactly divisible by 6. So this will be the roster form here. So in this we are going to write the domain here. So domain will be here 1, 2, 3, 4 and 6, and range will be 1, 2, 3, 4 and 6 here. Determine the domain and range of the relation R defined by R x comma x plus y such that x belongs to 0, 1, 2, 3, 4, 5. So here we are given the x elements here, and the condition given like x is equal to x plus 5 here. So when you are going to input 0, so that will be 0 plus 5, so you are going to get 5 output. Next 1 plus 5, so that will be 6. 2 plus 5, that will be 7. 3 plus 5, that will be 8. 4 plus 5, so that will be 9. 5 plus 5, that will be 10 here. So this is the outputs we are going to see. So they told write domain here. So domain, when you are going to see, so domain will be 0 to 5 here. So that will be 0, 1, 2, 3, 4, 5. And range, when you are going to see, range will be 5, 6, 7, 8, 9, 10. 5, 6, 7, 8, 9, 10. So this will be range here. Question number 7. Write the relation R x comma x cube x such that x is a prime number less than 10 in roster form. So here we are going to see the prime numbers less than 10. Here x will be 2. So 1 is not a prime number. 2, 3, 5, 7. So these are prime numbers less than 10 here. So here the condition given here, the y is equal to x cube here, then y will be x cube. So here we are going to input 2 here. So 2 cube, that will be 8. 5 cube, that will be 125. Next 3 cube, that will be 27. Next 7 cube, so that will be 343 here. So y elements we are going to see 8, 27, 125, 343 here. We are going to write in a roster form here. So that will be 2, 8, 3, 27, 5, 125, 7, 343. So this will be the roster form. So here domain will be x and range will be y here. Question number 8. Let a, x, y, z be 1 to find the number of relations from a to b. So here x elements are 3 here, y elements are 2 here. So we know the number of relations will be 2 to the power of 3 into 2 here. So that will be 2 to the power of 6. So these many relations we can form here. Question number 9. Let R be the relation on Z defined by R equal to a comma b such that a b belongs to Z. A minus b is an integer. Find the domain and range of R. Here the given data a comma b belongs to integer and a minus b is integer. So here the domain will be integer here and range will be integer because in the given data a minus b is an integer. So integer defined as z here. So d equal to z and r equal to z here.